Mr. Clelland Maths. Today we're going to do the whole volume in National 5 Maths. Remember to get the app, Clelland Maths app. It is app.clellandmaths.com, so you can go through all of this and all the other topics completely free of charge. Just download now. All of these questions are taken from maths.scot, an excellent website, so make sure you get on that as well. Example 1. Find the volume of a cylinder with base radius 6 millimeters and height of 1. So a cylinder looks like that, say. I'm going to draw this in white, of course. So its radius is 6, so 6 millimeters, and its height is 1 centimeter. Well, they're not consistent units, so I need to make them consistent. So I've got a radius of 6 millimeters, but the height is 10 millimeters. 10 millimeters to a centimeter. And the volume of our cylinder, well, it's πr² times h. Area of a circle times the height. Now, if you don't forget that, start of exam paper tells you that the volume of a cone is 1/3 πr²h. So drop the third, you've got a cylinder. So just sub in pi times 6 squared times 10. Well, that's a calculator job. Pi times 6 squared times 10 is 1130.973. Doesn't say any decimal places, but I'll just make that 1131 then millimeters cubed, or 1130.97 millimeters cubed. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code Clelland Maths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code Clelland Maths. Click the link to order now. Okay, example 2 on volume. Calculate the volume of a cone with a base radius of 3 and a vertical height of 5. Answer to 1 decimal place. Cone is given at the start of the exam paper. It is 1/3 πr²h. So we're just subbing in times pi times 3 squared times 5. So to do 1/3 in a calculator, there's a couple of ways to do it. Easiest way is 1 divided by 3 times pi times 3 squared times 5, and you get 47.123 centimeters cubed. 1 decimal place then, 47.1 centimeters cubed. And we're done there. Example 3 on volume, but this time non-calculator. Find the volume of a hemisphere, diameter 8. Give your answer in its simplest form. So a hemisphere is like half a sphere. So if it's half a sphere, if I know the volume of a sphere from the start of the exam paper is 4/3 πr², then it's that divided by 2, or half of that. So what's the radius? Well, diameter is 8, so the radius is 4 centimeters. And I have to give my answer in terms of pi, so I've not to actually work anything out, not 3.14, just leave it with a pi in it. So that equals 4/3 times pi times 4 cubed, but then a half of that or divide by 2 at the end. So 4/3 times pi, 4 cubed, 4 fours is 16 times 4 is 64, divided by 2. So that's 4/3 times pi times 32. 3 doesn't go into 32, so I can just times it by 4. 4 2s is 8 and 4 3s is 12. So that's 120 over 3 pi. And the units were still centimeters, so centimeters cubed. And that's about as good as I'm going to get, so I'm done there. Example 4 on volume, it's a calculator one. Find the diameter of a sphere with volume of 9 cubic meters. So we're working backwards. So remember, volume of a sphere is 4/3 πr². So we can find the radius and then double it to find the diameter. So we just sub everything in. The volume of a sphere, the diameter of a sphere with a volume of 9 cubic meters. So that means that 4/3 πr² equals 9. So we've got an equation to solve. So times by 3 to start with. 4 πr³ then equals 9 times 3 is 27. So I can work out r². That's 27 divided by the whole of 4 pi. and that means that r is the cube root of that. So calculator, cube root, brackets, 27 divided by 4 pi is 1.290. So that means that my diameter is double that. So about 2.58 meters. And we're done there. Example 5 on volume. A pyramid with base area 12 centimeters squared has a volume of 36 centimeters cubed. Calculate its height. So from the start of the exam paper, the volume of a pyramid is 1/3 times the area of its base times the height. So we're given the base area, so it doesn't matter what shape it is, and we're given the volume, so we'll just sub it in. So 1/3 times the area of 12 times the height equals 36. 1/3 of 12 is 4, so 4h equals 36. So h must be 36 divided by 4, which is 9 centimeters. And we're done there. SQA National 5 Maths 2016, Paper 2, Question 7. A carton is in the shape of a large cone with a small cone removed. So it's a takeaway. The large cone has a diameter of 32 and a height of 24. The small's got a diameter of 18 and a height of 13.5. Calculate the volume of the carton, and again, rounding involved to two significant figures. So we do the volume of the big cone minus the volume of the small cone. So let's just do that, right? So the volume of our big cone is, remember, volume of a cone is 1/3 pi r² times h. Given at the start of the exam paper, 1/3 times pi times, now the radius is going to be 16 because it's half the diameter, and the height is 24. So we get a mark for doing that and getting an answer. The answer to that would be 6433.98 with a bunch of other numbers, centimeters cubed. Now we do the small cone. The volume of the small cone, 1/3 times pi times the radius, which is 9, half of 18, squared, and times the height of the small cone, which is 13.5. We put all that in our calculator and we get 1145.11 and a bunch of other numbers, centimeters cubed. So we've got one answer, two answers for 2 marks. And then we get a mark for knowing that we need to take away. So our volume is equal to 6433.98 minus 1145.11. And that gives us, using the unrounded figures to take away, 5288.87. And then we get, for rounding our final mark, 2 significant figures it says. So that equals 5300 units, centimeters cubed, for 5 marks. A volume question, SQA National 5 Maths 2017, Paper 2, Question 6. It says a spherical sweet is made coating caramel sphere evenly with chocolate. A cross-section sweet is shown. The diameter of the sweet is 22 millimeters and the thickness of the coating is 3 millimeters. Calculate the volume of the coating. So the volume of the coating is not a full shape, so it's a takeaway again. So I need to do the volume of the big sphere minus the volume of the small sphere, and that will give me what's left in between. So it's a takeaway. So let's do our big sphere first. The volume of a big sphere, remember from the start of the exam paper, 4/3 pi r². 4/3 times pi, and the radius, well, we need to do a bit of maths here, I suppose. If I draw a dot out here and go to here, well, that's half of 24, which is 12. So it's 12 cubed. And that gives us 7238.229. 7238.229 centimeters, millimeters cubed in this case. Now the volume of our small sphere is 4/3 times pi, and the radius of a small sphere, Well, let's do a bit of maths up here. So I need to go from the middle to here. Now we already know that this bit is 24, but the coating is 3. So if I take away 6, 3 from either side, 24 minus 6 is equal to 18. 18 divided by 2 for the radius is equal to 9. We get 9. So it's 4/3 times pi times 9 cubed. In a calculator, we get 3053.628. So that means the volume of our coating is equal to 7238.229 minus 3053.628. That gives an answer of 4184.601, which when rounded to 3 significant figures, I think, in this question, well, that means I need to go 1, 2, 3 and round here, so it's 4180. 4180 millimeters cubed for our final mark. Another volume question, SQA National 5 Maths 2018, paper 1, question 17, had this one. A square base pyramid is shown in a diagram. The square has a base length of 6 and the volume is 138. Calculate the height. So this is a working backwards volume question. So math stages, there's a few ways you could do this, but math stages is always to write down my formula, then work backwards. So from the start of the exam paper, the volume of a pyramid is 1/3 times the area times the height. Okay, so substituting everything in, I've got 138 on this side equals 1/3 times, now it's a square, so it's 6 squared or 6 times 6. I'll just write 6 squared times the height. Stage we can do 138 equals 1/3 of 36 times h. 138 equals, well, 3 into 36 goes 12, so that's just 12h. And then we can work out h. 138 divided by 12 is equal to 11.5 centimetres. And that is one of the simplest ways to work it out. You could have also just made h the subject of the formula and worked it out, but there you go. SQA National 5 Maths 2021, paper 1, question 14. The diagram shows a hemisphere relative to the coordinate axis. A is 6, 0, 0, C is the midpoint of the diameter, and B is below C. Find the coordinates of B. Well, let's have a look at this one. If I get my coordinates up, then you're going along and along to get 6. The whole thing is 6, so half of 6 is 3, so I need to go along 3 first of all. And then once I've went along 3, I don't go in or out, so that's 0. I then move down 3 again, because a hemisphere means it's going to have the same distance here and here, because it's a radius. So down 3, so that's minus 3. Watch out, I'm going down the way, so it's minus 3. 3, 0, 3. 3, 0, minus 3, and we're done there. The volume of a hemisphere, we leave the answer in its simplest form in terms of pi. Well, the volume of a sphere is 4/3 pi r cubed, so our hemisphere is that divided by 2, or times 1/2. Now, our radius is already 3. We've already worked it out in part A, so that's 4/3 times pi times 3 cubed divided by 2. So I'll just leave the fractions till later and work out the 3 cubed. That's 27, 3 times 3 times 3, divided by 2. 27 divided by 3 is 9. So that's 4 times pi times 9 divided by 2. 4 divided by 2 is 2 times pi times 9. That's 18 pi units cubed. And we're done there. SQA National 5 Maths 2023, paper 2, question 9. The concrete block is in the shape of a large pyramid with a small pyramid removed. The large pyramid has a square base of 90, as you can see. The small pyramid has a square base of length 40 and a height of 48. The whole block has a height of 60. Calculate the volume of the block. So, a big pyramid minus a small pyramid. So go to the start of the exam paper and check the formula for a pyramid. You will see that it is 1/3 of the area of the base times the height.
So the volume of a pyramid is a third times the area times the height. So our big pyramid we'll start off with, that's a third times. Now the large pyramid's got 90 on the bottom square base, so 90 times 90. And the height, 60 plus 48 is 108. So we'll just get a calculator to work that out. 291,600 centimeters cubed, I suppose. And then the small one, that's going to be a third times 40 times 40 times the height of that pyramid, which is 48. That gives us a total of 25,600. Volume of the block is just a takeaway. 291,600 minus 25,600, 266,000 centimeters cubed.
Maths 2024, paper 2, question 7. A paperweight is in the shape of a cuboid. It consists of a hemisphere of red glass surrounded by clear glass. The cuboid is 4 centimeters with a square base of 7 by 7. And the hemisphere has a diameter of 6. Calculate the volume of the clear glass in the paperweight. So obviously the hemisphere takes up some space. So I need to do the whole volume minus the hemisphere. So I've got the volume of a cuboid. So the volume is going to be 7 times 7 times 4. Hopefully you can all do that. Minus the volume of a hemisphere. Well, check the start of the exam paper and you'll get 4/3 pi times r cubed. Now, let me just write that up here. That is a sphere. So the radius is equal to 3, because it's half of 6. So 4/3 times pi times 3 cubed. But I need to do a half of that, or divide by 2. So times a half or divide by 2, because it's a hemisphere. Now, most people work these out separately. So 7 times 7 times 4 is 196. Minus 4 divided by 3 times the pi button times 3 to the power of 3 is 113.097. Divide that by 2 or times it by a half is 56 point. Now, it wasn't two significant figures, so just a reasonable number here, 54866, blah, 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 and I've above it to round until at the end, 196 minus 56.54866. Now, it would have been 67 actually, but I've put ... so I'm safe there. So that gives me 139.451 and a bunch of other numbers, and I only need two significant figures, so I'm rounding here. That rounds up to 140, and the units are centimeters cubed. And there you are, there's your volume of the paperweight glass. SQA National 5 Maths 2025, paper 2, question 2. Shop sells footballs in the shape of a sphere with diameter 21. Calculate the volume of a football, 3 significant figures. So start of the exam paper, volume of a sphere is 4/3 pi r cubed. So I need to work out my r. Well, r is 21 divided by 2, which is 10.5. So it's just 4/3 times pi times 10.5 cubed. Get my calculator as usual. 4 divided by 3 times the pi button times 10.5 to the power of 3 is 4849.048. I need to round that to 3 significant figures. So that's 4, 8, cut in here, 9 goes up to 5 then, and 0. 4850 centimeters cubed. And we're done there. This is Mr. Clelland. Today we've done the whole of volume in National 5 Maths. So remember to download our app, app.clellandmaths.com, for everything you need to do your revision. Take care, stay safe, and goodbye.